All right. This one we're going to solve complex equations or solve quadratic equations with complex solutions and simplify expressions that involve complex numbers. Specifically, we're going to be looking at multiplying two expressions with complex numbers and how that works. So remember that if we want to write a complex number in standard form, that means that I want the real part to come first and the imaginary part to come second. And if I have a binomial term times a binomial term, this is like 3 plus 4x times 5 plus 2x. And we have two methods of doing that. Either you can use FOIL or you can use box. So if I'm going to set it up with the box first, just because it's kind of more visual. So I have a 3 and a positive 4i, and a 5 and a positive 2i. Then I just multiply corresponding spots here. 5 times 3 is 15. 5 times 4i is 20i. 2i times 3 is 6i. And 2i times 4i, well, 2 times 4 is 8, and I times I is I squared. But remember that I squared equals -1, so you will have to do a substitution in here. And so you'll end up with 15 here, 20i, 6i, and 8 times -1 will be -8. So it might not be necessary to rewrite this. I just thought that it would be clear then, because now I want to combine like terms and I want to put the real part first. So notice how this 8 here becomes a real part. So 15 minus 8 will be 7. And then 20i and a positive 6i is a 26i. If you FOIL it, you'd get the same thing as you do in the box. First would be 3 times 5, 15. 3 times 2i is our 6i. Then 4i times 5 is 20i. And 4i times -2 is the 8i squared. And then you would simplify or plug in the -1 for I squared and combine like terms, and you get the same answer. Let's do one more like that. I think I'm going to do C particularly for the point of this video, because I want you to see what happens here when we have 1 plus 2i times a 1 minus 2i. So these are the same expressions except for that one's a positive and one's a negative. So to multiply these, I'm going to take 1 times 2i and 1 minus 2i. So 1 times 1 is 1, 1 times 2i is 2i, 1 times -2i is -2i, and 2i times -2i is -4i squared. And remember, I squared is going to be -1, so that's really going to be -4 times -1, which will be positive 4 here. Now look what happens along my diagonal this way. A 2i and a -2i, that actually equals 0. So when the expressions are the same, but one includes a positive and one includes a negative, those are called conjugates. And what happens is that the middle terms end up canceling or reducing to 0. And so now we're left with is just a real number. 1 plus 4 is 5. B, this example would be very similar to the example I did in A. So look at the class notes if you'd like to see that one worked out. So we needed the idea of the conjugate here to do the next example. I want to write this in standard form. Right now it's as division. Really, this says we have 2 minus 7i divided by, that's what that fraction bar means, 1 plus I. And I want to write it in standard form, which means I want to write it as a plus bi. And so in order to do that, you actually have to multiply it by the conjugate, because the bottom, I want to get rid of this bottom piece. And so remember, if you multiply by an expression by its conjugate, which this case would be 1 minus I, then the imaginary pieces would cancel or reduce to 0, and I'd be left with just a real part. So that's what I'm going to want to do. But since this is a fraction, you're going to have to keep it balanced, essentially. Like if you change 2/3 and you multiply the bottom by 2, you also have to multiply the top by 2. So 4/6 is the same thing as 2/3. So in order to keep these equivalent is the word I'm looking for, you got to multiply whatever you multiply the bottom by, you got to multiply the top by the same thing. So you need to multiply by the conjugate of the bottom, which means if it's plus, you change it to minus. If it started minus, you change it to plus. So I'm going to FOIL just to save a little bit of time here. And again, you could use the box and draw the 2 by 2 box, but I'm going to FOIL. So 2 times 1 is 2. 2 times negative I is negative 2I. Negative 7I times 1 is negative 7I. And negative 7 times negative 1 will be positive 7. And I times I is I squared. So that's the top. I will have to reduce that, but I'm going to do the bottom now as well. 1 times 1 is 1. 1 times negative I is negative 1I. I times positive 1 is plus 1I. And I times negative I is negative I squared. So let's reduce that a little bit. Remember that this will be a negative 1 here, this I squared, and this I squared will be negative 1 as well. On the top, I'm going to combine like terms. I'm actually going to get 7 times negative 1 is going to be negative 7. So 2 minus 7 will be negative 5. And a negative 2I minus 7, negative 2 plus negative 7 will be negative 9I. All over negative 1I plus I reduces. So, and that's what I wanted it to be. So I cancel that. Then I have negative minus negative 1. Really, this becomes plus 1. So I have 1 plus 1 is 2. Now I wanted it to look like A plus BI. So I just need to separate this out. And that'll be negative 5 over 2 minus 9I over 2. Now both of those are odd, so I can't reduce that. So I just leave it as 5/2 and 9/2. And there we go. We'll do one more. I want to multiply by the conjugate of the bottom. And I want the bottom to be A plus BI before I begin, which it is. The real part comes first. Now this is a negative 2 plus I. I leave it as negative 2. I just change it from plus to minus. If it was minus, I would need it to change it to plus. And then whatever I do on the bottom, I need to multiply by on the top as well. So foiling the top, I get 3 times negative 2 is negative 6. 3 times negative I is negative 3I. I times negative 2 is negative 2I. And I times negative I is going to be negative I squared. Over, so remember FOIL, first, outside, inside, last. Make sure you multiply the 3 by each thing, and then the I by each thing. So on the bottom, get negative 2 times negative 2 is 4. Negative 2 times negative I is going to be positive 2I. I times negative 2 will be negative 2I. And I times negative I will be negative I squared. So look what happened on the bottom. That's what I want to happen. I want the imaginary part to disappear on the bottom. And not disappear, but equal 0. Then on top here, I'm going to have this I squared. I'm going to substitute in a negative 1. And this I squared, I'm going to substitute in a negative 1. So that's going to leave me with negative 6 minus negative 1 will be negative 6 plus 1. So on the top, I'm going to have negative 6 plus 1 is negative 5. And negative 3 minus 2 is really like negative 3 plus negative 2, so it's negative 5I. All over, 2I minus I was 0. And then 4 minus negative 1 is really 4 plus 1, which is 5. Again, I want this to be written as A plus BI, so I'm going to separate out that fraction. Then they're going to be both over 5. And now I can reduce, and I can reduce both of these. So negative 1 minus 1I. Sometimes you can reduce both fractions, sometimes you can reduce one, and sometimes you can reduce neither fraction. So reduce what you can,